I missed a few streams. Hope things are going well. Things are going really well. All right. Alejandro 404 official. Welcome to the party. All right, I think we're. Oh shit! I forgot to. Damn, I messed up. I didn't change my thumbnail, man. All right, I just changed my YouTube thumbnail thing. I used the old one by accident. All right, here we are. I'm ready to party now, man. Wait, is my sound working? How come I can't hear nothing? All right. I guess it's okay now. All right, you guys ready for Type Racer? We hear the Windows sound. Yeah, sorry for being annoying with that sound. All right. Are we good? Is it time to party? Yes, it is. All right, Type Racer real quick. First race, warm-up. Second race, championship round. No, Conor Chris is 2 ahead. Yeah, he won a couple last time, maybe. All right, there's the link for Type Racer. Let me post it in the Discord. Little Freezy in the house. What's happened? What I mean last stream as a bachelor? I'm getting married tomorrow, man. That's what I mean. So this is like my bachelor's party. Don't Defense is gonna teach us segment trees. That's what we're doing for my party. Where's the cocaine? Come on, man. It ain't here. Hold on. What was I doing? I'm trying to do this dang Type Racer. That's what we're trying to do. Learning segment trees for a bachelor's party is a life choice I'm not convinced I agree with. What do you mean, man? You're the one teaching us. Anyways. Are y'all ready, Type Racer? I sent you the links. Alright, let's go. First race, warm-up, second race, championship round. It's only me and Don't Defense. Look at that. Type Racer is broken on Firefox. Yeah. Type Racer sucks, man. Jesus, 158 Pixel Pusher warm-up round. Q Ultimus 108. Very nice. I got a nice speed, but unfortunately only the warm-up round. Is it even worth racing when Pixel Pusher is there? Yeah, because you never know when he might not race. Sometimes he just sits out for no reason. Like, well, we don't know. We don't know if he's going for 100 wins or what. All right, here we go, man. Championship round. Are y'all ready? It's only a few of us, but let's do it anyways. Here we go. Man, I messed up so bad. Don't defense 108. Jesus. Getting faster? I don't know, man. I think I'm like the same. Man, don't defense won that with 108. I had some bad typos on that one. Alright, let me put that up on the board and then we'll start. Maybe I'll do the daily problem and then don't defense is going to teach us the segment trees. So don't defense just won that type racer 108. Dang, look at that. Neck to neck for second place. Bobby Blue, what's happening? And how you doing, Pixel Pusher? What's happening? Let's learn fast seg trees so I can overkill prefix sums with it. What are fast segment trees, man? I don't even know what that is. Or you mean just learn it really fast, or what? I will yoink some Python seg tree template and wonder if it will work. Make your own template? Alright. Anyways, I guess we have a few minutes before Don't Defense jumps on. In the meantime, let me see if I can do the daily problem in like 15 minutes or so. Iterative seg tree is the faster one. Wait, what are y'all talking about, man? I don't even know different types of segment trees. Daily problem is a speed run. Oh man, we'll see about that. Build array from permutation. Given a zero base permutation nums, zero index. Build an array ants of the same length where ants I equal nums I for each I within bounds and return it. A zero base permutation nums is an array of distinct integers from 0 to n-1 inclusive. What are you talking about, man? Oh, ants I, okay. Wait, Taurus cheese problem D at MIT IT finals? What do you mean cheesed? Wait, iterative seg tree? Wait, you can cheese something with iterative seg trees? I don't know what that means, man, because those are, I don't even know anything about CodeForces and real competitive programming. You know, non-intended solution. I guess that's what everybody does for linked list problems on LeetCode. Alright, here we go. Let me solve this real quick. So what are we doing? We're trying to say ants equal nums I and nums I. So if I just iterate and then ants I equal nums I. Should I just do that? Just do what it tells me to do. Anyways, not a very interesting problem for me. Still not as cheesed as whose ONQ solution. I don't know what y'all talking about, Raxo. Norwegian Euler. How you doing? O1 space requires a bit of thought. Wait. Oh, I didn't even see the follow-up. Let's see what the follow-up is. Do you mean O1 as in we don't make this answer, we just return nums? We do it in place? That's what they want? Congrats on under 15 minutes solve. Ice Cold Witch, thank you very much. Alright, let's see. Dang, Norwegian Euler, 2 years and 2 months almost. Alright, in place. So they want nums I to be ants I equal nums I. What does that mean, man? So this means this is tripping me out. It's like we got to do some type of swapping, or do I just swap nums I with the current index or whatever it is, and just keep swapping until I can try, but I don't really. While nums I not equal to I don't know what to do with this. Wait, what are y'all talking about, man? Everyone went to him after the contest because it was one of the harder problems, and he was like, Donald just printed minimum NM. That's how it works at these high level contests, man. Anyways, nums I. So I gotta swap that. All right, let me try. Before I code it, let me just try and like do a dry run or whatever. All right, so here, this needs to be there, so I'll just swap these things like that. Maybe. Oh no, but then I need to remember what was originally there, man. How the hell do you do this in 01 space? Let me give it some more thoughts. In place. So we know there's without using extra space. Well, I mean, it's 1,000 numbers. I suppose I could do an n squared solution where I just iterate from, so I like search for the lowest number first. That way, let me think about that. I don't know if this is a great solution though. So if I did the zeros first, then I'd like swap these. And then if I did the 1 next, then I'd like, oh no. No, that's not gonna work either. Because this number is there. Alright, let me think. Am I doing the follow-up? Yeah, I'm doing the follow-up. How to do it in 01 space without using, like, how to just do it in place. I might not have time to solve it though. Stuck on the original? Come on, man. I just solved the original. How are we gonna do it, man? Huh? Rexo, is this easy? Should I know how to do this without thinking too much? Or what? Because it's not obvious to me what to do. Oh, Brett, what's happening? I think it requires an idea. Yes, I don't have any ideas right now. I was replying to being stuck in the original comment. Oh, I see. No, no, not. Wait, this is the follow-up for sure. How do you do this in place? So 5. I don't know. Man, it requires some interesting ideas. The official in-place solution is so dumb. I hate it. Well, I haven't seen it yet, but is there like more than one in-place solution? Wonder what can we do? Look at hint 1? No, I'm not ready to look at the hint, even though I don't know if I'll ever get this. So I've thought about swapping something, but then I don't know. I don't know what to do. Like, how do you remember what number was originally there if you move something, you know? It's not about the follow-up, just funny? Alright, let me see. Just apply what's said in the statement? Yeah. I guess that's a good hint. Just do what the problem tells you to do, man. What's the big deal? I mean, that's what I did. Alright, I don't have any great ideas. So this needs to be whatever is in position 5, which is 4. And this is 0. Might help if you draw the permutation. Draw it. What do you mean draw the permutation? Which one? Like the input one or the output? I guess they're both permutations. Alright, let's try and do some drawings here. Well, I got 5 minutes before Don't Defense has to give me this segment tree lesson. So this goes here. This goes here. That goes there. What are we doing again? That goes there. Is this like some type of traversal? Did I mess up somewhere? Like, so if I started from this one, then I can like do some type of traversal and move the numbers along the way. So if you start maybe like a DFS where we enter from index 5. And then we carry that number 4 to index 0. No, I don't know. Traverses cycles? Yeah, wait. Draw, yeah, it seems something like that, but I don't know how to implement that yet, at least. So it hit. How would he hit that, man? So did he just go from 0? This is the beginning. To. No, wait, 5 is the beginning. Wait, it's basically just these numbers, right? So I just start in order and I'm just. I think I'm confusing myself. Cycle idea, don't hate, didn't realize it's a permutation, but their official solution is so annoying and dumb. Wait, let me try and. I only got 1 minute. Maybe I might just cut it short so we can get on to segment trees. The official solution is stupid. Now, kind of want to see it. So this is like. Is that the order? 0, 1, 2. Anyways, I give up. I'm willing to see some solutions for 01 space. If Pixel Pusher, Brett, Don't Defense, if anybody has solutions, I don't think I'm gonna code one up, but I'd like to see. Alright, official LeetCode solution. In order to allow the construction process to proceed completely, we need to enable each element nums I and nums to store both current value and the final value. Wait, what? They're just adding the number to it. Yeah, that seems a little bit silly, but I guess it works. Or something. So it's like. Oh, don't defense. Let me see here. Looks a little crazy, I'm not gonna lie. Wait, what are you doing, man? Who knows what this is? What? Subtracting? Adding something back? I would have never come up with this. Yeah, a little freezing. Me neither, man. That means it's visited. Oh, I see. This means it's visited because you subtract this big number from it. Or something. Yeah. A little tricky problem for sure. At least in 01 space. But I wouldn't know how to code that up, man. Not in a couple minutes at least. Alright, Brett's coding up the other solution. Pixel Pusher, did you have a solution? Or did you just kind of do it a weird way, like the editorial way? Yes, Brett's coded up. Nah, but he said he solved it, or he asked me about the follow-up. Did he even consider it himself? Nah. That's not true. That's not true. Alright, well. Are we ready for... Wait, I need headphones. For when Don't Defense gets on the call in a bit. I'm nervous, man. I got to go learn these segment trees. I think Don't Defense probably gonna put me on the spot. Give me some type of pop quiz that is gonna check if I'm paying attention. We'll see. Very nice. Oh yeah. I believe you. I believe you. Don't worry. But you have a lot of knowledge, man. You're so lucky. Wait, how am I lucky? I only yell if things going really, really bad. All right. We'll see how that goes, man. We'll see, we'll see. Yeah, I've been putting this off for about 3 years now, man. 3 years I've been supposed to learn segment trees, and 3 years have gone by since I've done it. No pressure? Nah, there's no pressure, man. Anyways. Should I do a little audio check with my headphones? If you fail to understand, it's gonna be your failure. Yeah. It's the if I don't understand it, it's because I have a bad teacher. Of course. Everybody knows that. Don't Defense voice review, man. Don't Defense has streamed before. Yeah, he streamed a few times. Alright, alright. Anyways, should we do it? What are you saying? What do I need? What do I need to do? Do I need Discord? Alright. Here we go. I'm about to call you Don't Defense. Let's see if it works.
Hello, can you hear me?
Alright, I can hear you, man. Can you hear me? Can everybody hear Don't Defense? What's the audio like? Too low, too high?
Too low, I can make it higher. But I'm not sure if Discord is gonna stop. It's gonna like...
No, I can adjust it on my end. Alright, how about now? It's great now? Okay. Alright,
okay,
Don't Defense. First, thank you so much for coming on stream and teaching us segment trees, you know. I've been avoiding this for a long time, man, so thank you very much.
Yeah, they're not... In my opinion, they're like... After you like learn them, they're like pretty easy to like use and understand. But at the same time, they have like a high ceiling. So like don't get too much into like, oh, I need to learn everything about segmentation. Just learn the basics, and that's like gonna unlock a lot of problems. Okay. Especially among like the harder ones.
Yeah, I've never really used a segment tree, so I don't even really know what they're useful for or anything. But usually when I'm doing LeetCode and it's a problem where I think a lot and then nothing comes to me, chances are it's probably segment tree.
Yeah,
So
that happens lots of times. Okay, so can you see what I'm writing?
I'm in the Excalibur, but
Maybe try moving. Scroll back to content. I see a button on your screen.
oh yeah, I see some things.
Do you see? Okay, yeah, perfect. Okay, so first let's like talk about like a classical segment problem. So what do we use it for? So I guess the first thing is that it's usually used like on like a list of elements. You can use it on other things, but like that's the main thing that you should think about. And I guess the classical first usage that we should use is like, let's say that you have, an array of elements, 1 minus 2, 3, 5, minus 4. This is a very bad 4.
This is
And
very bad for.
and let's say that you want to do queries of the type, what's the sum between like the fourth and seventh element, or basically some queries. What would you do?
Like prefix sum.
Prefix sum, exactly.
Yes.
But now, if you have like updates as well, prefix sum no longer works, right? Because like it's gonna take linear amount of time to like update the prefix sum. So this is like one of the perfect usages for this. So basically, you have like queries of the type sum LR. So like, give me the sum between left and right. And then you have like update of like an index.
Yes. All right. I have a question. This may or may not be relevant, but doesn't a Fenwick tree also do very similar things?
So the Fenwick tree does exactly this. Okay, I wanted, but let's say that instead of like sum, let's say that we want the max.
Oh, I mean, I don't want to
So-
like derail you. Maybe you had something
No,
planned, but
it's the same thing. It's basically the same operation, but Fenwick tree can do max between left and R.
okay.
So let's
And this
switch to
is
max just so that
so max is something that a Fenwick tree cannot do.
yeah. So Fenwick tree can do like max between like 1 and like a position P, but it cannot do between like a left and a right. So you can only
Yes.
do prefix.
I see.
But I think like when we're gonna code the problem, we're just gonna code like a sum problem, and then like the second problem is like a bit more bespoke.
Okay.
Okay, so how do we actually use what is a segment tree actually? Well, a segment tree splits like the numbers. So let's like write the indexes. So 1, 2, 3, 4, 5, 6. I'm just gonna make it a power of 2 just so it's a bit easier.
One indexed. Okay.
Yeah, you can create it one index or zero index. It depends like however you want to create it. So what a segment tree does is it creates like a binary tree, so that the root of the binary tree contains the information about the whole interval. So in our case, it's going to contain the information from like 1 to 8. So this is the index from 1 to index 8. And then it's going to have like a left child and a right child.
All right.
And the left child, you split the interval down the middle, and the left child will have exactly the left part of it. So it's going to have, in this case, 1 to 4. And on the right side, it's going to have 5 to 8. And we're going to keep doing this. We're going to keep splitting down the middle and do 1, 2. And in this case, it's going to be 3, 4, 5, 6, to 6, to 7, 8. And then, and these like last nodes are just the leaves. Right? They're just going to be like 1, 1.
Yes.
1, 2, 3, 4, and so on. So what are we gonna store in all of these, nodes? Well, we're just gonna store like the answer to our problem. In our problem, the max. Every one of these nodes will store like the max between the left index that it has and the right index that it has. So for this array that we have like above us,
Yes.
the leaves, I'm gonna write the values in like red. So this leaf has like value 1 because it's like the only element inside of the leaf. This leaf has value -2 because it's -2, it's the value.
Yes.
This is gonna be 3, 5, -4, 6, -2, and 1. And now, how do you combine, how do you calculate this node? Well, you just look at the left node and the right node, then take the max between the two. In this case, it's 1. Now, max between 3 and 5, it's 5. Max between -4 and 6, it's 6. Here is 1.
I
And
see. Yeah.
5, 6, and then 6 at the end, right?
Man, your 1s and your 7s look.
There's no
Wait.
7s.
Oh,
so
wait.
my 1s and the 7s.
Your 1 looks like a 7, man.
Look at the 7. The 7 has like a
Okay.
nice tiny
Okay, the
thing
7
here,
has a cross. Okay, I see. I see.
right? So, for example, how many nodes are there in total? Like, let's do like maybe a bit of like complexity calculations. How many nodes are there in total?
Wait, what do you mean? Like 8 nodes?
Well, there are 8 leaves, but how many nodes are there in this whole tree?
Oh, 1, 2, 3, 4, 5, 6, 7, plus 8.
Yeah, so 15. So what it's equal to, like, right, the n leaves, and then how many are going to be at the previous level? They're going to be n over 2 leaves, and in the end they're going to be like +1, so it's like about 2 times n nodes.
Okay.
So there's just a bit more nodes than actually the elements in the list. Now let's see, after we constructed this is like the initial version. Let's how do we update the segment tree? Well, let's say that we want to update like the third position to make it from like 3, we want to make it to, let's say, 7. Well, we're going to go down the tree. We're going to go down the tree, we're going to go at this node, and then we're going to go, where's our position? Is it to the left or to the right?
Right.
Well, to the left it's 1, 4, so we're going to go to the left. Then we're going to go, again, as the same question, we're going to go to the right.
Yes.
And then we're going to go to the left. And now now in the relief, we can just change the value. We can make it 7. And now when we go back up, we can just recalculate everything. Right now it's max between 7 and 5, 7. Between 1 and 7, 7. And between 7 and 6, 7.
I see. So that can be updated in like log n time.
Exactly, log and time, perfect. Now, how do we do queries? Let's say that you want to do like the query to 7, let's say. You want to get the maximum between the interval between 2 and 7. So you're going to do almost the exact same thing as a query. You're going to start at the root, and you're going to look at the current node. And if the current node is completely included in the query interval, then we're just gonna like return the value inside of the node. In this case, we're comparing 2.7 with 1.8, and 2.7 doesn't completely include 1.8; it includes a bit more. So then we're gonna have to like recurse, right? We're gonna have to recurse to the left because a part of the query is included on the interval 1, 4, and then we're also gonna have to recurse to the right because a part of the interval is on 5, 8, right? So we're gonna go to 1, 4. Let's just simulate that. We're gonna go to 1, 4. Does 2.7 completely include 1, 4? No, because it has like the 1 extra part. And then we ask, is any element included in 1, 2 from our query? Yes, there's 2. So we go to the left as well. Is 1, 2 completely included in 2.7? Well, not really, because it still has the extra 1. do we have anything from the left that's included in 2.7? No, because it's just 1. So we don't actually recurse to the left, but we recurse to the right because 2 is included. So we're gonna have to take the max between -2 because that's our first element.
Okay.
Then we go back up. Do we need to go to the right? Yes, we need to go to the right because it includes it. Now we're at 3.4. 3.4 is completely included in the interval 2.7 in our query interval. So then we don't actually need to recurse to the left and to right because it's already completely includes it. So we just do a max of what's inside of this. So 7. And then we go back up to the 5.8 interval. Is it completely included? Again, no. So we recurse first to the left. And then 5.6 is completely included, so we add that as a max. And then we recurse to the right. Is 7.8 completely included? No, because it has that extra 8. So we recurse to the left first. And then we get a -2. And then we don't recurse to the right because 8 is not included at all. So then we just get the max of these like values. So like in this case, the values that we actually visited, I'm gonna like mark in red, I guess. So like we're gonna visit like this node that's like includes only 2. Then this big node that includes 3, 4. Then this big node that includes 5, 6. And then this big node that then this small node that includes 7. And you can see that all of these nodes together form the interval 2, 7.
Yes. So, all right, I have a quick question.
Yeah.
Is there some type of limit to how many queries you'd have to do to cover any interval?
So perfect. Let's calculate the complexity of this. This is a perfect question. I was about to go to this. You just sniped me. So let's calculate the complexity. So I think the easiest way to explain the complexity for this is like let's think about the query. Let's say that the query is like 1x, just for simplicity at the beginning, right? So the query is 1x. Well, what will the complexity be in this case? Well, if you're at a node, like at some node, if you need to go both to the left and to the right, let's say that you're at, I don't know, let's see, the query is like 1, 5, and the current node is like 1, 4. Sorry, the current node is 1, 8. So the left node would be like 1, 4, and the right node would be like 5, 6, 5, 8. So in this case, you see that you need to recurse both to the left and to the right because 5, 8 is included in both locations.
Yes.
But if you can observe is that what you can observe is that when you take the left node, well, the recursion will just stop at this node because 1, 4 will be completely included in 1, 5.
Yes.
Because at the beginning, it's basically if it's touching the wall, right? If it's touching the wall at the beginning, then whenever you split, like if you have this interval, whenever you split and it was previously touching the wall, well, then this node will just stop recursing instantly because you'll get the value. The other node might recurse for more, but you're only gonna have this. You basically solve a part of the problem.
Right.
So if you think about it, how many times do you split? Well, you're gonna split log n times max, like log n times again. You're gonna split.
Wait, come again? So you're saying the time complexity is still log n, but it's probably like 2 times log n, which is still log n.
Yeah, exactly. Yeah, it's like 2 times log n. And then if you think about like what if the query isn't like 1x? What if the query is like some arbitrary left and right? Well, the first time you're gonna split this arbitrary interval left and right, like let's say that we split it like this. Well, now this red interval is basically exactly the same as like our 1x interval. Well, it will behave the same. So it's gonna have like log n intervals, because now it's touching the interval. It will never
Right.
not touch the left interval. And exactly the same for the let me make it blue, for the blue interval. Now it's going to always touch the right part, so it's again going to be log n steps.
All right, so also log in to do that.
Yes. So also log into that. It's like a very nice data structure. So basically, more or less, this is like the version 0, let's say version 1 actually. This is like gets you so far into it. Do you have like any questions before like we discuss a bit of like implementation?
Yeah, I think this makes sense to me, what you're explaining here and everything so far.
Yep. Okay, so let's talk a bit about how would you implement this and how we are going to implement this right after we finish this. I'm going to go a bit more down. So you can see that what does every node have? Like every node has like itself, in this case like an ID. Every node is going to have like L that represents its like left part of the interval. Every node is going to have like R that represents its like right part of its interval. And more or less all of these things are constant. These won't, after you create the data structures, these won't change.
Yes.
Right? Like if you can look, you can modify the internals, but these won't change. So usually in most standard implementations, these are actually like arguments to the function. Like for example, you're going to have like a function update. It's going to take like the node ID, the left interval, and then the right interval. And these, you always calculate them for every node.
So,
And then you're going to have...
sorry, question about what ID is. Is ID like the index?
It's exactly
in
the
this
index.
Case, not the value,
Yes, exactly.
right?
Yep, the index.
Okay.
So this is like the index in like whatever structure you're holding in. And I don't know if you ever implemented a priority queue by hand, but there's this like nice trick that you can use for binary trees, is that you can make the root be ID 1, and then make the left node be ID 2, and the right node be ID 3.
I see.
And then you just continue this way. The left node of this one is ID 4, then 5, 6, 7, and so on. And it's very nice because the left child is equal to its parent child times 2. You can see that
Yes.
it's like 1 times 2. And the right child is equal to the parent child times 2 plus 1.
Yes.
So initially when you like query the segment tree, you're just going to give it like ID 1 and just like 0n or like 1n, whatever, if you want to be a 1 index. And then inside of this function, you're going to calculate the ID of its like left parent, you just multiply by 2. Of its right parent, you just multiply by 2 and add 1. And then you also need to calculate the middle and the middle, right? Because you're going to split it to like left mid and then right mid. Right, sorry, mid plus 1.
Yes. I
Right.
see. Yeah, right.
Right. So these are like the most important details. So like how will like the update code actually look like? Update is gonna look something like, it's gonna take like ID left, right, the index you want to update, I'm just gonna call it I, and then the value, I'm just gonna call it V. Oh,
Uh-oh.
I got a weird error, but let's continue.
Yeah, I
right?
saw it.
So if we're at a leaf, so when are we at a leaf? Well, in case L is equal to R, we're at a leaf. Then we just like do like, in this case, I don't know, I'm gonna call it max array, max A, of like the ID is equal to like V, right? Otherwise, wait 1 second.
Okay.
Excalibur is misbehaving.
Yeah, maybe. Should we go on to a new sheet maybe? Maybe it's getting like too big. There's too many objects.
No. Let's finish and then we can just go to like a LeetCode shared session and
Okay.
start implementing, right? Else you just calculate the middle, and then if the index is to the left, this means like to the left, then you basically what do? You update to like ID times 2 because that's the left child, L mid, and then just the query values. And then else, if it's to the right, then you like do the same thing here, just like for the right node. So I think this is like 2 plus 1,
Yeah.
or something like that. And I think this is like, anyway, this changes. This is like mid plus 1. And then the update function, the query function is exactly the same. You just recurse, you just see if your interval is completely, if your like LR is completely contained within the query, then you just return the value. Otherwise, you see if you have to recurse to the left or to the right.
All right.
All right, let's look at implementation, because that's how you like. If you don't have any more questions, let's look at like a problem and implement it, and we can get more. We'll get more questions maybe during the implementation. But do you want to start like a LeetCode live session or whatever?
Yeah, let's do that. Let's do that. I don't know. How do you do a live session? I guess I just choose any. Do you have a problem in mind? Maybe I should go to that.
Oh yeah,
problem?
I sent you a link. I sent you a link
Oh,
on Discord.
I see. I gotta get to my Discord. Here we go. Oh, I've already solved this one with a Fenwick tree.
Fenwick
that
tree, yeah.
Brett
But
taught
let's solve
me,
it. Let's
yeah.
solve it with the.
All right. So how do you make this? I don't know if I have the live coding session. Unfortunately, I think that's a premium feature.
Let me see. Okay, then I can watch your. I guess I can watch your stream.
Okay.
Or we can use a third-party tool, but I don't know what third-party tools are
Yeah, I'm not sure either.
usable nowadays. So let's just. I'll watch your stream.
Okay, you can do live in Playground. All right, let's try that. Wait, are you sure you can do live in? Oh, share. I need to save
There's a
it
live
first.
button down.
Okay, I just saved it. Alright, I'll send this to you on Discord.
Okay.
Let's see if it works. Well, it says not connected. I don't know if that means I'm not allowed to have live things.
Maybe press the live button.
Yeah, it says not connected. Have you tried?
I already joined.
Oh, so you're here?
I tried typing. I typed things already.
Oh, I haven't seen anything.
What happens if you refresh? Do a refresh? Connecting.
Yeah, I guess it doesn't work. They need to spend more engineering time on it.
They need to do better LeetCode interviews.
I know, man. What are they doing out there? All right. So should we just do?
Let's Uh, just do it, and I'll watch the
Yeah,
stream, I
yeah.
guess.
Okay.
Okay, so this problem is exactly what you described, but instead of max, you can do sum.
Okay, should I read the problem first for everybody?
Yep.
Range sum query mutable. Given an integer array nums, handle multiple queries of the following types. 1. Update the value of an element in nums. And 2. Calculate the sum of the elements of nums between indices left and right inclusive, where left is less than equal to right. Alright, that's it. I'm not going to read the rest. Okay, so
So let's start writing the update function first.
oh man, you're gonna have me do this, huh?
Well, yeah, I'm not.
Oh yeah, alright. So
So create like a global function, like update. Like name it like maybe update tech3 or something like that.
wait, say what? Name
Name like a custom function, yeah.
like make a new
Like not
function.
global or
A void
yeah,
or
exactly.
something? Or what?
Update is void, yes.
Alright. I don't
And what are the constants in every node?
Oh man. Oh, I see what you're saying. So we need like an index
Yep, an
and we
index.
need I guess the sum. Wait, a left and a right and wait. We need the left, the right, the ID,
Yep.
which is the index, and then we need the sum of
Yeah,
the
but the sum isn't constant, right? So we just need the first three variables of this function will be the constants, in this case ID left and right.
Alright. So wait, what are we doing? Am I like literally building the nodes, like the tree nodes
Yeah, yeah.
and stuff?
We're literally coding upper
Oh
segment 3.
man, you put me on the
Come on,
spot,
Simon, you
man.
can do it.
Come on.
This is it's so just write so sim update will just first three parameters of the functions are just the constants. It's
Oh,
just gonna be
I see
like
what you're saying.
ID left and right.
Oh, Hector HSC, thank you very much for those bits.
Yep. And then the last two variables will just be the query. So in this case, index and val.
Oh man, but so this is updating the tree, but I haven't even built the
This is
tree yet,
updated.
so I'm gonna have to create that somehow.
So in this case, the tree is just like an array of like elements. So just declare like a vector of int of size, let's say 4 times num plus something.
Like,
So just name it sec3, a vector of int sec3.
a vector of ints only?
Yep.
That's crazy.
Yeah, because every other thing will get created in the function. Every other information that's constant about the sec3 is you're gonna generate it on the fly while like going around the sec3.
Okay.
So then you only need to keep outside of like the functions. You only need to keep the things that might change, the like dynamical things. And in this case, it's just like the sec3 value.
Oh, you mean like we'll have like a lefts or a rights or something like that? Or
No,
wait, maybe I don't know what you're
yeah.
saying yet.
the lefts and rights, we're just gonna create them on the fly, right?
All right.
So, first part of the update, if the current node is a leaf, we just update it, right? We're just done.
Okay. I'm having difficulty trying to visualize this. So how do I know? if it's a leaf or not, because I'm so used to seeing the tree class, the tree node class thing.
Yes, so this might be like a bit of an unorthodox implementation for like a tree, but it's like used a lot in practice. For example, it's used in like priority queues and stuff like that. So it might be like a bit of a slow start, but I think you're like gonna get used to it.
Okay.
So in the case of the segment tree, when is it a leaf? Can you say anything about like the interval
Well,
when it's a leaf?
I know it's a leaf when it doesn't have any left or right nodes.
Yeah, but think about the left and right value. Think about the current interval that it's representing. When is it a leaf?
I guess when the left and right are equal.
Perfect. Yeah, exactly. So if the left and right are equal, then we can just update the current ID.
Huh. All right. Where is this left and right information gonna be stored? For
So it's just going to be stored in the function, right? It's
in
you can think
function.
about it as a constant.
All right.
For each ID has the same, always has the same left and right.
Okay. All right. So if it's a leaf node, you say we can update the value.
Yes. So seg s of ID is just equal to the value.
So it changes, not segs.
That's why I said seg s.
All right. So this is. Wait, what's the difference between this ID and this index?
So the ID is the internal ID of the node, and the index is the index in the list.
Okay.
Right? Like if you get a query update like update position 5, well, you need to find the ID of the leaf with position 5, right?
Wait, say that one more time.
If you get an update to find position 5, you actually need to find the leaf that has that position.
Man,
So if you go, let's go back to the drawing, right?
All right, let's go back to the drawing, man.
Okay, so let me just draw. I'm gonna draw. Where am I? I'm gonna draw here like a quick seg tree of like 4 values. So like this represents like 1, 4, 1, 2, 3, 4, and these are the leaves that represent like 1, 1, 2, 2, 3, 3, and 4, 4. So when you get a query update of the type update the third position, well, you actually need to find this node that I'm gonna like circle in red to actually update it, right? So to find that node, you need to find its ID. So what are the IDs in this case? Well, the leaf is like ID 1, and in this case, if you go to the left, it's 2. This one is like 3, 4, 5, 6, and 7. Right? So the IDs are these numbers inside of the node, while in our case, our query value is the index inside of the list. So don't forget, the seg tree splits it into like sub arrays basically.
Yes. All right. So the ID is always gonna be just 1, 2, 3, 4, 5, 6, kind of like in order.
Exactly. Yes.
Okay. Man, this is tough. Because. All right. So what are we trying to do now? We're trying to write this update function.
Yeah.
I'm just looking at what you wrote down here. So you're saying if left equal right, this is a leaf node. And this is like some information in another function, right? Like
this is the information inside like some
or not
array
other
that you're
function.
storing.
Yeah, some other vector, not the seg tree one. This would be like sums or whatever of the ID.
No, this is like the seg tree node, right? This is the exact seg tree node that you want.
Oh, so like the seg tree, the
Because this is
value.
the ID.
Right,
Yeah.
so this value will be the sum here. And
Yep.
then, oh, so now we have to do the traversal where we're saying like,
Yep. And it's if you look at the code again, it's ID, not IDX. Right? IDX is the index of the list. ID is the index of the node.
this is gonna be trippy, man. All
It
right.
is, but
All right.
and now
Man.
and now we just need to do the traversal. So now this is exactly like a binary search. You need to calculate the middle.
Wait, we need to calculate the middle,
Of the interval.
like straight up regular middle,
Straight up regular binary search.
something like that.
Yeah.
And then this middle, wait, I'm not too sure what we're doing here, man. We're taking this middle and then we're saying,
So let's look back at the drawing. So let's say that we're in 1-4. Well, in this case, the middle is like 2, right?
yes.
So middle is 2. So right now when we're updating, we want to figure out, is the value that we're trying to update on the left node? Or is the value that we're trying to update on the right node?
Oh, I see what you're saying.
If it's on the left node, we
Yes.
recurse to the left. If it's on the right node, we recurse to the right. So exactly like binary search.
Yes,
If
yes. It makes complete sense now. So this is our midpoint. This will determine whether we go left or right. It's like the border.
Exactly.
And then the number we're looking for is the index, not the
Yep,
ID.
exactly.
So we're checking like
Exactly.
if the index is less than the mid, then go left. And then if it's, I guess, if it's equal, then it should be
If
a
it's
leaf node.
if it's
or
no, if it's less than or equal, it goes to mid, because like if you look at the drawing, the left node represents
oh yes,
from like
yes.
left
Yes.
to middle,
I see.
and the right one represents from middle plus 1
Yes.
to right.
Makes sense. So how do we go left? I guess we will go left by, I'll call it the function.
Yep. So
wait.
using the trick, the left node
Oh wait,
ID
we have
is-
to update these left and right things, right?
Exactly, we need to update them right here.
Yes, so the left, let me think about that without trying to look at the Excali draw. So if we're going left, that means we're going from left to, I mean, can I just say mid here? Or no?
Yep.
Or is that okay?
Yeah, that's okay.
That feels right, yeah. And then the IDX still stays the same and the value still stays the same.
Yep. But what about the node ID?
Does that change?
Yeah, you need to multiply. Don't forget, it's child.
Oh, right.
It's the ID of
I
the
see
child.
what you're saying. Yes. And this one would be like mid plus 1 to right. Yeah,
Perfect.
this is
And now-
all
and
strange
now-
to me because I'm so used to doing everything binary trees with these struts or these classes, you know?
Yeah.
and
But this
stuff.
is like way faster in practice.
Okay, right.
And it's way easier to code. So now that you updated, now we need for the current node that's like not a leaf, we need to update its value, right? So in this case, seg3 of ID will be equal to the sum of its left child and the sum of its right child after all the updates are done.
Oh, so the sum of its left child plus the right child.
Exactly.
So you're saying seg tree how do you know that? Hold on. Because seg tree, what's the left child? How do I know what the, I guess the left will just, let me think. How do I know what? Okay, the left child would be like that.
Exactly, the left child is like that.
And that would be like that, right?
Exactly.
I see.
You're perfect. Good. So this more or less completes this. You just completes fully the update function. This is the whole update function.
Okay, everything makes sense now that I've had some time to think about it and see it.
And let's say that you wanna make a sec tree of max. Now you just this line that's like currently 23 on my screen. All you need to do is make sec tree of ID is equal to max. Exactly.
Instead of adding them, yes.
Yep, exactly.
Oh.
Yeah. Now let's write the query function. So what I would do is just like copy this whole function and just rename it, and let's build from there, because you already have like lots of the pieces are in common, but they're sufficiently different that you don't want to
Okay.
like it's hard to so now ID left and right remains the same, but now it's a query, right? So instead of IDX and val, you need like left query and right query. You can name them, I'm not sure how you want to name them, but you can name them like left keyword and like, yeah.
All right.
So in what case do we just, and it shouldn't be void, it should be like, I guess, int to return the sum.
Oh, yeah. All right, so...
Okay, so what, now when do we actually stop recursing? Because like we won't stop if we stop at every leaf it's bad. We stop if the current...
The left and right, like, match up with the... Like, it's fully encapsulated within...
Exactly. Yeah, exactly,
left
perfect.
queue and right
If
queue.
if the left and right are fully inside left queue and right queue. Right?
Okay.
So let's do that if...
Oh, man.
Change that if left is equal to right to...
All right,
if it's fully encapsulated. Right? So if it's fully encapsulated, then the left query needs to be smaller than or equal to the left.
Wait. So, if it's fully encapsulated, you're saying the left...
If you go to Excalibur, I can draw the case, right?
Yes. Which one is fully encapsulated here? The query, right? Or the left? The left
and right
are fully encapsulated
in the query, right? Because then it's like good, and we can actually add this operation because we don't have any extra junk. If it's not fully encapsulated, we have some like extra junk to the left and or to the right.
Yes.
And we don't want to actually return.
So if this... That maybe?
So if left is bigger than or equal to right query and right is smaller than or equal to right query, perfect. Yes, exactly. In this case, we just return the value stored in the current node. So just return sec tree of ID.
I see. Yes.
And now we need to do the exact same thing as an update. We need to figure out if we need to go to the left or to the right. So here, you might need to go, in the previous one, you only went either to the left or to the right, but in this case, you might need to go to both. So I would just write like red value. So after mid, I would declare like some red sum is equal to 0.
And then we're adding it up here somehow. So, all right, let me think. How do we, if we have to, let me think about what this is doing. So the midpoint, so we're saying, oh, I see. So if the midpoint is within the left query and right query, that means we have to go both ways. If the midpoint is like less than the left, that means we go right, or less than equal to. Wait,
Yeah,
let me
almost.
think.
Like if you go back to the Xcoli draw, like let's say that this is like the middle, like left, middle, and then this is middle plus 1, and right.
Yes.
So there's gonna be three cases, right? So it's gonna be the case where you only need to go to the left.
Yes.
Like so, this is LQ and RQ.
Yeah, like the right Q is less than equal to the midpoint. That means only left.
Yes, if
And the left Q greater than the midpoint means only right.
exactly, and if it's like this,
Yes. The left Q is less than equal to the mid. And the right Q is greater than the mid. Or something.
exactly.
Yes.
Perfect. That's perfect. But you can usually write it something like this. You can usually write something if left Q is smaller than or equal to mid, sum plus equals to the query, and then another if, so you don't like write
Oh,
three ifs,
I
you can
see.
just write two ifs.
Interesting.
If mid is smaller than right Q, then sum plus equals to the right query.
Let me think about that for just 1 minute. So you're saying if the left query, oh, that means it bleeds over in the mid. I see. I was thinking about it a little bit differently, but I see why you do it this way. So you only do 2 checks instead of like
Exactly.
a triple thing.
So sometimes it's actually nice to do, like you can do it however you want. Sometimes it's like nice to do a triple thing, because you can just like return, right? Like this code doesn't need to be like sum. You can just do return the query,
Yeah.
right? And then in case it's both, you just do, in case it's like both, you just do return of combination, like combining the two queries, like query 1 plus query 2. So it has some benefits using your way as well, but this is how I usually code it up.
I'll try and remember how you do it, because you're a lot better at this than I am.
Yeah. One of the disadvantages of doing this is, like, for example, if you're doing max, you need to think about what's the default value. You want to put like minus infinity or something inside of the shared value.
Okay, so should I do this in the query function? So, all right, let me try and remember what we're doing here. I'm just gonna comment this out for now. So we were saying if the left query was less than or equal to the midpoint, then this one is sum, right? So we'll take our sum, and I guess it'd be similar to this. ID left, right, and then I guess we just have left query, right query here.
Yep.
And then if the right query is greater than our midpoint, then we got to go right as well. I'm just copy this. But here we go, 2ID plus 1, and then here we go, mid plus 1 to right. And then I guess we're returning the sum, so we just, I guess it's already added, so we just return the sum.
Yep, and you have, well, we didn't test, but now we have successfully written your first segment tree.
Oh, that's crazy.
So let's finish the problem just so we can confirm that it works.
I mean, if this works, I'm going to be amazed. But
so in
we'll
num array, just declare sec3. I usually declare like just clear the previous sec3 value.
Oh yeah. I don't know how to do that nicely. So
Secretary.clear.
oh, dot clear.
Yeah, and then just do secretary.resize nums.size times 4 or something. That's what I usually do. I'm not sure if I have a.
How much? What do you say?
Do n times 4. That's what I usually do. I forget why I do that, but I've been doing that for like 10 plus years, just so it has like enough. There's enough nodes.
N times
Plus-
4. Plus 4.
Let's say n times 4 times 10 or something.
Wait. N times
Sorry,
4?
n times 4 plus 10.
Interesting.
And then this is like all you need to do. And now you need to update every single value.
So it's called update. Wait, what would the ID be?
So the ID of the root is 1. Should you just put 1?
Oh, so we always go from the roots. I see.
Yep.
Wait, what were my parameters? Left, right, index val. So, and this would be. Wait, are we talking about one indexed here?
So the problem requires 0 index, so just do 0 index. You can do 0 and minus 1.
Well, should I make n? And then we're going index and val.
Yep.
Real Raymond Jones, what's happening? Thanks.
And let's do the same for
Coder share. Sorry. And then, so that's updating, and then the sum range will just query everything.
Just return the query. Yeah, exactly.
And we start from the roots.
Yep.
And I already forgot what the thing. Left query, right query. The naming is a little bit weird, but I'll get used to it, or I'll figure out.
Yeah, and
nicer
in the
names.
constructor, you also need to initialize. You need to call n updates to the array so it actually creates the array. You need to do like a for from 1 to n, from 0 to n, and then call update of the initial array, right?
Wait.
'Cause
Updates.
This problem gives you some initial values
Yes,
for the problem.
So these are the indices. Wait, let me see. How am I gonna update this? I guess I just call the update and then I and then the value at nums I.
Yep.
Interesting. And you're saying this should work?
I mean, yeah.
Should I trust? Should we bet? No, let's not bet here.
I would need to see the code before I'll put.
Yeah.
My,
Hey, you haven't been looking at the code. I thought you were watching what I was doing, man. All right. Friendly bet. You think it's gonna submit?
No.
I trust you, man. It's gonna work, man.
Very unlikely.
Yeah.
Very unlikely. But run. Do a run.
Come on, you didn't believe in your own code. Come on now. I believed. You didn't believe.
Yes, I'll admit I did not have belief that this was gonna work. But you can see how, like, I don't know, intuitive this like is.
No,
it's just like a bug.
I was struggling a little bit at first because this is the first time I've done any type of tree traversal without like just doing node left, node right. So, but once I figured out what you're doing, everything started to just make sense to me.
Yep. Okay.
Yeah.
Let's go for the. Do you want to go for? I would go for like another problem just so you get more used to it.
Okay. All right. This is the part where we copy our template.
Exactly. So like, in my opinion, for secretary, you should create your own template.
Yeah.
Like you can use like the AdCoder one that's very popular, but you created this model, like you created this, you know how this works,
so I can
and you will just get
update
accustomed
it.
with it.
Yes. Okay.
Okay, so here's the problem. You're given a list of n boxes. I'm writing in the Excalibur. and each box has like some space. In this case, like this is how much space it has. And what you want to do is you get some items. You get some items in a sequence. You get an item of like size 3, an item of size 6, an item of size 12, and so on. And what you want to do is when an item comes on the conveyor belt, you want to put it inside of the leftmost box that actually fits the item.
Okay.
So in this case, when you get the item of size 3, you want to fit it in the leftmost.
So this 5 box.
Exactly. So, and then the box, you cannot put more items in the box, you just delete the box. And now 6 goes to the 8 box because it doesn't fit in the 4 box. 12 is a fat item, so it just doesn't fit in any box, and so on.
All right.
So now the question is, at the end of this operation, how many items are not in any of the boxes?
Oh man. And I'm supposed to solve this with a segment tree somehow.
Well,
Or
either a segment tree or I'm giving you a completely unrelated problem to anything we discussed
yeah,
today. It's like a 50-50.
I mean, if you had given this problem without the segment tree lesson, I would have even think about segment tree right now.
Yeah, so that's why I'm like trying to get like at
Yeah.
least some intuition for like when segment trees are used.
Okay, so man, and we just need to know how many items didn't fit into any boxes.
Yes.
So
So
what,
if we're
I guess-
implementing,
Okay. Go ahead. Sorry.
so if we're having an item, so if you're if you're using a seg tree, what type of seg tree do you think we should use, just intuitively?
Oh man. Either some type of min or something, or
So
max.
why would the min work? Like
Min
in
or
this
max,
case,
I'm
the
not
min is
sure.
like.
Yeah. Well, yeah, I was thinking min or max. Maybe the max, because I was thinking min to see if the minimum, but maybe the max is right to see like the biggest
Well,
size box in a range. I don't know yet.
Exactly. So you kind of want the biggest box in the range,
Yeah.
right? So how can we solve? Solve it if you have like a seg tree of max?
That's a great question. I'm not sure yet, but it seems we need to.
So with the seg tree of max, we can basically ask an LR, ask an interval, and we can get the max in that interval.
Yes. But I'm wondering,
And
we like.
we want to find the position P so that
Are we
the like box size of P.
Maybe. And it has to be the leftmost box. So I'm thinking,
Exactly, the
is it
leftmost.
some type of binary search as well? Where we can binary search on the right interval to see how far?
Perfect. Yes. So
Yeah.
this was a problem that you did a contest on, and it was like a Q3. Pixel Pusher spoiled it by posting it in the chat, but this solution would have already gotten you like accepted. I think this just passes.
Wait, fruits into a basket?
Yeah, but I chose this problem because like there's also like a nice second trick we can use. So what would the complexity of this binary search be?
Wait. Complexity of this binary.
Of this whole algorithm, I guess, per yeah, of this whole algorithm, or like per item.
Oh man. That's a tough
How,
question because I'm not really comfortable with segment tree complexity yet. So
well,
let me just give it.
segment everything is log, right?
Everything
Every
is log,
operation
and
is just log.
update and query are both logs. So this is like, so you gotta do binary search. Is it just log n?
Well,
Because
not
it's
really,
not
right? Because
nested. It's like log n log. I don't even know how to represent log squared n.
yeah, log squared n, exactly. It's like log squared n because at every binary search step, you need to do a query inside of the seg tree.
Oh yeah, wait. Dang, my light just went
So,
off, but I don't think we need it. We'll be okay.
so it's gonna be like log squared because like every query is like log n.
I see. Yeah. Makes sense.
Okay, but a reason I chose this problem is that there's like also like a nice property of the segment tree that we can use. So let's look at the segment tree. Let's say that our current interval is like our like whole interval is like 1/8, and in the node we're stalling the maximum. Just by looking at this like root node, can you tell me if there's any box that's gonna fit?
Yeah. Because if the maximum is less than the current box, then nothing will fit.
Exactly.
Right.
If the maximum is less than the current box, then like there's already no box. So we can just stop here. But let's say that there is one. Can you figure out if the leftmost box is to the left or to the right?
Can I figure it out?
Let's say that we're looking for like a box of size 9. And the root says that it's like the maximum is like 20. And let's say that the left node has max box size 11 and the right box has max box size 20. So will the leftmost box be to the left or to the right that fits the item of size 9?
It has to be to the left.
Exactly, it has to be to the left because we know that there's a box of size at least 11 there.
Yes.
So we can just go to left. We can just ignore completely what's happening to the right,
Right.
and recurse. And then again, like what if, okay, now we go and the maximum to the left is to the right is 11, and the minimum to and the maximum to the left is like 7.
Means
Do we need to
gotta
go to the
right.
left or to the right? Exactly, right? So this like binary, because of like the binary search nature of like this data structure, you can actually, while traversing, you can do this type of binary search and figure out the query.
So that means alright, when I'm at the root node, to determine whether I have to go left or right, that means I'd have to peek at the left and
Exactly.
right nodes' children.
And
So
it's
that-
very easy to pick with this data structure because it's times 2 and times 2 plus 1.
Yes. And that's
Okay, let's
not gonna
try
overflow.
implementing it. And when you delete an item, you can just set it to have like weight 0, right? When you delete a box.
Yeah. I see. So should I just solve fruits in a basket, or what are you
Yeah,
saying?
let's solve fruits in a basket.
So I guess I tried this probably on the contest.
Yeah.
And I was
Yeah,
like,
I think this is
no.
what...
Yeah, I think I thought about this
This is-
problem for like a long time, and I was like, I have no idea what to do.
And if you don't have this, like, I don't know, Swiss Army knife, it's just like impossible. And you can't... It's very hard to come up with this in contest. So I would copy the seg tree, yeah? Just your Simon functions.
All right. And the seg tree, maybe. Well, right?
Yeah.
Okay.
Yeah, that as well.
So
So now it needs to be, instead of instead of sum, it needs to be of max, right? So let's
Right, right,
first
right. Oh,
transform this
let's
sec
modify
tree.
that then. You're right. So this would just be, there are negative values, probably not. So I guess 0 is okay here.
Yep,
And
exactly. Zero is
then
okay here.
we can say max mx. All right. Is that it? This, the update doesn't. Yes, it does change right here. And that's all the changes we need to do to make this into a max seg tree instead of a
Yep,
sum.
this is now a max sec tree. So some people actually like have this operation have like in their template.
Oh, like,
They define like
bool.
another function for this operation. They name it like apply or something.
Oh, I see.
And then they just change in one place instead of two places. But at the beginning, I'm
Yes.
not gonna make you make the perfect template.
Yes, I see. Well, for now, I'll just modify it on the fly whenever I need to. If I ever
Yep.
use templates in contests.
Well, I think if you're creating your own, if you wrote your own sec tree, you should use it as a template. It's like more using an add coder template is like maybe a bit more advanced and a bit more try hard, but your own template is more than fine.
Yeah, I mean, I think this seems relatively straightforward enough. Where
Yeah, I mean, if you practice enough, you'll be able to do it. Like I implemented both of these problems like blindly 2 hours
Yeah.
ago in preparation for this. So if
Yeah.
you have practice, you'll be able to do it. But it's like a skill that nobody tests for. And it's not an interesting skill to have.
Yeah, yeah. Well, I like to be a little bit strange, so maybe in the beginning I'll just try to do it from memory, or at least derive it myself. And then
Yep.
once I can derive it, then I feel comfortable to use templates. But anyways, let's try and solve this problem.
Yeah, so we need to modify the query, right? Instead of returning like, instead of getting the max on the interval,
Oh, right,
you're
we
just
have
given
to.
a single value. You're not given left, like you're just getting like size or like item size.
Oh, right, right,
And you
right,
need
right.
to return an index.
Oh, yes, I see what you're saying. So this is just gonna give us a box size. And then
Yep.
we have to make sure that this box size, wait, let me think about what we're doing here. We had to peek at the children. So how do I make sure that we're not going out of bounds here? Is it because of how we initialize our segment tree to n times 4 or whatever you did?
Yeah.
That means it won't go out of range, right? So
Yeah,
then,
that means it's not gonna go. ID isn't gonna go out of range, and if left and right are initially set well, then it's gonna also not gonna go out of range.
okay, so I need to just give it some thought. So if this box is like less.
So first, let's write the base case. That's already like if we're at a leaf,
So if we're at a leaf,
then we found the leftmost box, right?
I suppose you're right, and we just return this index.
Which is left.
Or right, yeah.
Yeah, left or right, exactly.
And wait, this query is returning the index so that we can then update it to zero it out.
Exactly,
Yes,
exactly.
yes, I see what you're saying. But then we need to figure out
Actually,
go
yeah,
left
actually,
or right.
exactly, go left or right. And actually, let's write the real base case, because the real base case should be if it's not possible, right? When is it not possible?
Oh yeah, so if did I put seg tree? Seg tree. So if that is less than that, then how do I know it's not possible? Return -1 maybe?
Yeah, -1.
And then now if it's there, this is the correct box. And then
Yep.
now we
Now
have
we
to
need to
yeah.
choose left or right.
So how do we choose that? We have to look at segtree, the left node value, which is ID times 2. So if that is greater than or equal to the box, then we should go left.
Exactly.
And then otherwise, if times 2 plus 1, then we go right.
Yeah, you don't even need an if statement, right? Because you checked at the beginning if it's impossible.
Oh yeah.
So if you can go left, you can go
Yes.
right. But it doesn't matter.
Yeah, I'll leave it in there just to be explicit. So, alright, going left, what does that mean? That means we're going to just... So we just return it? Let me think about that. So, this is the old stuff. Wait, hold on. This is querying, so we're not updating anything. We're just trying to find the box. So maybe this is all obsolete. I'm just gonna erase it for now. So if we go left, then we just we still need the midpoint. Let me get that midpoint. And then I can erase it. Wait, do we need the... We do need the midpoint, yes, because that's how we know what to split the left and right thing. So this is ID times 2 because we're going left, and it goes from left to our midpoint, and then the box doesn't change. And then here we'll go from mid plus 1 to right, and ID times 2 plus 1. Yeah. And then now everything is good, and we just use this segment tree in the code, right?
Yep.
Should we try that now? All right. So first we need to create the dang segment tree thing. Should it be... I guess it doesn't need to be global here since it's not one of those range query problem things, right? So and then you try and initialize
Well, it still
this.
needs to be global, right? Because your functions access it. You can pass it as a
Oh,
reference.
right. Yeah. You
But the
are
functions still
correct.
need to have access to it.
You're correct. I've been using the dang lambdas for too long. Well. Alright, so I gotta try and remember the syntax that you say. Dot clear and resize to n times 4 plus 10 is a safe number.
Yeah.
And now
You can also do seg3 is equal to vector of int of n times 4 plus 10, right?
vector, wait, seg tree, yes, I see.
But this is just how I use it. I don't know.
Yeah.
I don't think there's any good reason for me to be doing this.
Well, you need to clear if you just initialized. I guess it's just good practice. Q. Sometimes
So
you
to
get
answer
garbage values.
Q's question, like LeetCode actually runs it multiple times, right? So you might have junk values from a previous test if you don't clear, and if you just resize.
Wait, Bets, if you don't know seg trees, man, come on now. Alright. So we created a seg tree, but we have to update the values, so... Do we have to? Yeah, we have to do this, right? So it's like... Update... on... The ID is one is the root, left and right. That would be just 0 to n minus 1, and then index and the value. So that means just that. It's updating. So once we create the segment tree from the fruits, wait, from the fruits or the baskets? Let me see real quick. I think it's the baskets we need to create this for.
Yeah, it's the
My
baskets.
bad. Yeah, and then they're of the same size, so we can just update this to baskets. So now we have the baskets or the boxes in our segment trees, and then now we can iterate over our fruits. And let me think what we're trying to do. We're trying to binary search on the right. So like we're going from 1 or from index 0, and we're binary search on the right side where we can find a correct box that fits. So once Simon query returns a -1, that means it's bad, right? So let me try and figure that part out now.
So don't forget the binary search is baked in to your solution.
Oh yeah. So I don't actually have to binary search here because it's
Yeah,
already
the stick is doing.
Thank you.
The binary search.
I was about to go do
That
my
was the
own.
initial solution. So from what I looked at the list of solutions, so even if you like didn't know sec trees well enough to like do this trick, you'd have gotten accepted in contest. So, but it's better to like know the internals of sec tree, and you can actually use its power a bit more nicely than just hammering things.
Wait, so now that you say that, let me try and shift my mental a little bit and readjust. So we're just querying the whole root for the box. That's it. And then maybe I want to count like how many we don't find a box for. So we're just querying the ID is 1 because that's the root node, and then left to right would be 0 to n-1. That's the whole range of all the nodes, and then the box size is just gonna be fruits I, and then we can say if this is -1, then we have a fruit that we haven't found a box for, and then if it's not -1, then we have to update something to 0 is what you're saying. Is that what the problem is asking? Return the number of fruit types that remain unplaced.
Yep.
Is it gonna work? Do you think it's gonna work?
Do a run
No,
first, but
no,
if you
we
want
can't
to
hit run. You gotta tell me, yes or no.
I think no, I don't believe. I just never believe. I never believe.
Oh,
and
man.
it took me 3 runs and 2 submits to get it right. So
I mean, you've been guiding me though, so
yeah, but no, when I'm saying when I implemented it, it took me that much.
uh-oh. Oh man.
Oh, see, this is why you should have just left the else. You said I forever remember you said I'll
Yeah.
leave the else for clarity or like for
Yeah, I have something like this happens to me in real life, at work, in production, and I caused not me, but my team caused a big outage with some type of bug like this, some undefined behavior. But anyways, I'm just gonna return, I don't know, something. Let's see now.
Yeah.
Whew. Perfect. Wow. Very nice.
Okay, nice.
I'm amazed at how simple this was.
Yeah, it's like after you start using it and after you like understand it, it's like just such a simple data structure and so useful.
Yes. So obviously, like, segment trees can get way more complicated than this, right? This can't be
Yeah.
it.
Yeah, so let me just if you let's go back to like I guess the escalator. So let me just like explain to you like one more extension that's like very classic, but I'm not gonna like make you code any problem because like for example, there's so few LeetCode problems that actually use this, and I think you should just solve like if you want to learn segmentism, you should focus on like the vanilla. But it's good to know that this extension exists. These like two extensions that we're gonna talk about. So for the first extension is like it's exactly the same problem as before. Like you had a query of like left right, but now the update is of the type, instead of being a point update, so you just update an index, like you want to update the whole range. So you want to do the whole range between L and R. You want to add plus val to it.
Oh yeah, I've seen these.
You can actually do this problem. You can do if you just if the queries are just point queries, so it's just like q of x, just a point. You can actually do it with your type of with the normal type of segmenting. But if it's like range updates, then it's like a bit harder. So what changes about like if you want to do this? This is like called in like the community or whatever. This is like called like a lazy sec tree. Oh my god, my pen is not working well today. Okay, so this is called like a lazy segment tree. So the only change that you need to do is currently we're just keeping like one array. We're keeping the array of like segment tree that includes all up-to-date values of the array. But in this, when you want to do a lazy sec tree, you're also going to keep like a like lazy to update, let's call it. So like to update, it's also an array, and it's also like one thing per node. Update. It's also one thing per node, and what this stores, what this tells you, if this is set to something, it tells you that hey, this value inside of here is not yet updated. You need to add to it the current thing that is inside. The current thing that is inside of to update. And if you have this, when you're doing like a update query, you can do the exact same thing as when you were doing a query. When the current update query is like completely contained inside of the like query, you just update this value, which will tell you in the future, hey, if you ever want to access this node, be aware that this node is like not yet updated. You need to update it with the information that's stored here. And after you update this node, you also tell your children, hey kid left and hey kid right, you also need to update yourselves with this information. So you push this like update down on the leaves. So this is like more of an advanced topic, but this is like high level how it works. You just store an extra variable per node that tells you, before you access this node, make sure to update me in this way. In this case, like for example, for some, it could just tell you like how much do you need to add, like you need to add plus 10 whenever you access this node. And then when you access this node, you push plus 10 to both your children. And then you, if it was like 5 before, you apply the operation so it becomes 15. You set to update to 0 because you currently applied the update, and then you push the to update to the children. This is like an advanced thing. I'm not like, if you want we can like have another session, but it's like good to know that the sector can do this, because sometimes you might encounter a problem and like, oh, this looks like it's like a sector, but I need to do range updates. So I'll Google it, or like I'll figure it out.
All right. I'm not 100% sure what you just said, but I think I get some parts of it, you know?
Yeah, so you only need to be aware that you can do, for some operations, like some, you can do updates per the whole interval.
Yes, I see.
Right? So and it's like not hard to implement, but it's like gonna take some time to like fully understand how it works, which I don't think we have
Yeah.
time right now.
Okay.
And and another usage is that secrets can actually be used in like very strange ways. Like, do you remember the like classic DP problem, like house robbers? Like, let's say that you have like some houses.
Oh yeah. House robbers for sure.
Yeah. So with a secretary, you can actually like, if you have like the values of the goods inside are like 3, 5, 11, 4, 8. With a secretary, you can actually answer the query about like what's the best robbing sequence. I think in this case it's like 3, 11, and 8.
Huh. I don't.
Right?
I was trying to think briefly, like, how would I even use a seg tree here?
Yeah.
And-
So, but you can actually use a secretary by like in an interval LR. You would actually just need to store the information needed to combine it with like, let's name this actually mid. Like, you actually need to store the information about how to combine it with like mid plus 1 and R. So in this case, how would you use it? Well, you would probably store something like, okay, what's the best I can get if the last house I don't rob? What's the best I can get if the last house I do rob? And then combine this with the exact same thing. What if I rob the left house? What if I don't rob the left house? And what if I do rob the left house? Right? So you would basically store like a 2x2 matrix in this case that tells you all the possible interaction, all the possible combination between robbing the left house and robbing the right house.
Sounds a little crazy. I don't really
Sounds-
see
yeah.
it, but
Sounds a little bit easy. And then if you have the same information about the right interval, then you can basically combine, right? Because like let's say that you wanna combine, let's say that you wanna calculate for the big interval that you don't rob any of the houses, right? Well, that's equal to you don't rob the left house of this interval, but you do rob the right house of this interval, plus you're not allowed to rob this house anymore, right? Because like that would make 2 consecutive robberies. So you're not allowed to rob this house, and then because this is 0, you're not allowed to rob this house as well. So you can just do like these combinations, these like crazy DP on interval combinations to like get the problem with updates. So again, this is like super advanced. Like usually it's like a Q4, but it's good to like just good to be aware of this.
yeah. So I'll keep this in mind, but I don't really understand, like,
Yeah,
how to use it.
you don't need to understand. You just need to be aware that this is like a possibility. Like this robbing problem with with updates was actually given as like a Q4 a while ago. I remember I did it in contest.
Oh shit, 15% acceptance rate. Yeah.
Yes, so you can look at like my solution, just so you can like smell how you would do something like this. But you can see that like, just look at the how I merge 2 nodes. It's just like insane. It's just like a bunch of DP maxes, just like combining intervals in like crazy ways. And you can see I'm actually storing like 4 different arrays, one for each one of those states that I mentioned.
Yes, I think this is a little bit beyond my abilities,
Yeah,
for sure.
So this is currently it's beyond your abilities, but it's just good to be aware that like this is like an option. Who knows? Maybe you solve the first 3 questions easily, and then you have 1 hour to try to solve a crazy safety problem.
Yeah.
And if you're aware, you can also like just Google information.
Yeah. I Google a lot during contests. I'm not gonna lie.
Yeah. So this is just like a good thing to be aware. And the like, I mean, there's some safety stuff that are like so advanced that like I never use them in contest.
Yeah.
For example, you can like make the safety persistent. So like you can ask it, hey, 100 queries ago, how did the safety look? And you can
Oh,
actually have the
wow.
safety
It's like
answer
version
that.
controlled.
Exactly. It's like version control for sectors. I think I might have implemented one or two problems, but never in contest, for example. So
Wow.
this stuff is like more or less just fun facts to know.
So, how long did it take to get to Grandmaster? Like how intensely were you studying when you were training for that arc? And like, tell us a little bit more about that. I'm very
I did not
curious.
prepare for an interview, Simon.
No, just one quick question, man, because everybody
Uh,
wants to know
y-
how you got to Grandmaster, right?
you need to contact my agent for further discussion on this stuff. I'm joking. I'm
All right, how
joking.
many
I
hours
don't
do you
know.
think you studied is what we really want to know.
During my whole lifetime, like it's hard to know. If you look at like my profile, you can see like bursts of like practice. I think in like December. So
Let's pull
the
up
story
your
was that,
profile. Can we pull up your profile
yeah.
on
So like,
CodeForces?
yeah. So like in November, I forgot the name of the contest.
Wait, your name is not Don't Defense though, is it?
No.
Can you link your
Uh,
profile
yeah.
just so that everybody's aware of who you are? Look at that, Grandmaster, crazy.
So like I don't know. The last year I kind of practiced, but it was just like solving an easy problem. It wasn't like clear practice. And then in November I decided that okay, I need to do like a contest, and I like practice seriously. I did like lots of, um, I did like lots of, uh, virtual rounds. Like I
Yeah,
was doing one every couple of days, and I was like plotting my, uh, I was
yeah,
plotting like my,
yeah. Your like your
uh,
rankings or whatever, your performance.
yes, some of them were bad, but like overall, all of them were like mostly above Grandmaster. And then I think in November there was a contest that like I had to like not do officially, let's say, that I would have gotten to me GM, but I was like sick or whatever. And after that, I was just like practicing and like, okay, I know I can do this. So I was just like doing virtuals, doing like problems and so on until like I got it. So
Oh,
it was like very intense until then.
so you
But
recent Grandmaster. I thought you were like a lifetime Grandmaster. Not that it matters
no, it
to
wasn't
me,
a
man.
lifetime.
To me,
But
you are Grandmaster always.
so I think I just was like stressed doing contests. If you look at like 2017, I think at that point I was like grandmaster level back then. Like if you look, I
Yeah,
like got I don't know,
right here.
a 2,700 performance or something. But I was just like not in the mood to do contests.
I see.
But then afterwards, like I just did. You see, I didn't do any contests between 2017 and 2023, and like actually, like it was a bit rough, like coming back to like grandmaster level. It like wasn't trivial. It wasn't just like come pick it up. I had to do like some
Yeah,
decent amount of
serious training.
practice. Yeah.
Wow. So would you say over 10,000 hours of studying in your life?
I'm not sure. I'm not sure. I think you can do it if you like train correctly. You can probably do it fast. Like I don't know. I don't know. Like for example, like I don't have that many problem solves. Like 1,000 problem solves overall isn't that many compared to like other people.
But you've solved more than this for sure, right? Um,
Not like
like with
real
other
problems. Not many more
accounts.
than this.
I see.
Like I think I have some like couple of hundred solved on like top coder, and maybe couple of hundred solved on my like on the like Romanian evaluator. But
Huh.
not that many more. But I do think a lot a lot about problems.
Do you think you could beat Rexo Sabe in
What?
competition? Do you know Rexo?
Yes, in Rexo.
I don't know who's
I don't
better.
know his profile.
It's hard for me to see who's like the number one leak coder out here or the number one competitive programmer.
I know that I think Rex was like faster than me, but maybe at a harder problem I
Yeah?
could
Huh.
I could take him on.
Interesting.
But at the same time, at the same time, uh, Rexo did a problem for like a contest that I participated in, and that problem completely fucking wrecked me. Like it was
Yeah.
insane. I was like, I asked him, hey, who proposed this problem? And he was like, me. And hey, how do I solve it? And he told me the beginning of the solution, and I thought for 30 minutes. And I went back to him, hey, okay, so how do I solve this part? And he was like, oh, just do this. And then I thought for another 30 minutes to an hour, and I'm like, fuck, I don't know. So I go back to him, can you please
Yeah.
give me like a solution? And he gave it to me, he was kind enough, and then I understood. So he's good at like proposing very nice
I see.
problems that wreck me.
Yeah, interesting. Because to me, all you guys are just so far beyond my abilities. It's hard to know who is actually better or anything. Like, you know, like seeing numbers or AWICE. I don't know if you know those names, or even like BetSimp. I put all of you guys in
Yeah.
the same category, just people who are mega guardians on LeetCode, but there's clearly levels to it, even in CodeForces.
Yes,
you
so,
know?
so like for example, I think both Alex Weiss and Raxo Sabe are like faster than me, and probably LeetCode are like way better than me. But maybe
Right.
at CodeForces you get an advantage if you're able to like solve harder problems that might take a longer time.
Yes, I think that's
So maybe that's when I sometimes get an advantage.
yeah. My biggest strength in LeetCode is, I'd say, my speed for easier problems, but my biggest weakness is I can't solve hard problems at all. You know.
Yeah, so for hard problems you need like intense training. It's like frustrating. Like
Yeah.
so many times I like think for like 2 hours on a problem and I like then have to look at the solution. It's like very, I don't know. It's like very mentally challenging, right? Because like you feel defeated. You're like, okay, this problem defeated me, so you need to like get over that. You need to like, I don't know, be more optimistic. It's like a different mentality change trying to like solve really really hard problems.
Yeah. So did you also do ICPC, like Raxo and a bunch of other?
Yeah.
Yeah. And did you make it to finals and stuff like that?
Yeah, I went to the finals
Oh,
once.
one time only? Come on, man. I thought you'd go at least
Well,
twice.
you can only go twice, and we were in a hard regional initially, so I have excuses.
All right, you have to like compete with tourists and them type of people. Maybe.
Yeah. Well, I wasn't with tourists, but I was with some like really really strong teams
Yeah.
that like I had all 3 members were like better than me, right? So it's like hard to win against them.
Yeah. And you say you're still involved in competitive programming because you just did the MIT photography thing?
They had I was only a grandmaster, so a grandmaster there just takes photos, doesn't actually participate.
Yeah, okay. So everyone there is like a legendary grandmaster or something?
No, not all of them, but yeah, like lots of
Or
them were
international?
like super high up.
I guess there's international that.
Yeah, lots of them were IGM, but there were like lots of LGMs as well. Like I don't know the rating of everybody, but
Yeah.
lots of above 3,000 were there.
Yeah, I see. So, do you have plans to do more competitive programming in the future? Maybe like a coach or something like that, like what Raxo does. Raxo is a coach for some ICPC teams.
So maybe training, but like I don't know, it's like very time intensive, and it kind of depends if you have like dedicated people. Like I do like help like friends or like people that locally want to, but organization I'm not sure. It's like so involved that it's like hard to
Yeah,
do.
I get it, man. Are you working currently?
I'm a PhD student.
Oh man, getting paid the big bucks. PhD. When do you
Yeah,
graduate?
very big book, guys. I have no idea. Like in 2 years in theory, but who knows?
Oh man, you must be doing some crazy research. I don't even know what PhD people do, but
So I'm doing like the research is like closest to like LeetCode problems. or like
Wait,
not LeetCode, but like
like
algorithm
you're
problems.
inventing some new algorithms, or you're trying to invent a new algorithm or
Yeah,
something?
yeah. So for example, one of the domains is like sublinear algorithms. And what does like what does sublinear
Like
algorithms
log n?
are exactly like log n? But like for example, a classical problem that I worked at is like you're given like a binary matrix, and you want to tell if like the image is connected or not.
Hmm.
Right? Well, you just do a DFS in the normal environment. You just do a DFS, and you see if it's a connected component or not.
Right.
But in the like sublinear sense, you're given like a matrix, and you can query its points. And you're given two test cases, more or less. You're given two types of knowledge: either an image that is connected, or an image that it's very very far away from connected. So the question is, if you're only given these two types of images, like one that is guaranteed to be connected and one that's like you need to change a lot of pixels to like make it connected, can you differentiate between the two? And if you're given this type of problem, you can actually differentiate between the two in sublinear time, so you don't need to look at all the pixels.
Oh wow. That's all. I guess this is like when you say connected, like an image that looks like another image or something, right?
So connected is just like the LeetCode problem, like island connected,
Oh,
up,
like
down, left,
that.
and right.
Like MS Paint bucket fill
Exactly.
or whatever.
Exactly. If bucket fill would change every pixel, every black pixel.
Yeah. Huh, so that's what PhD students do. Try to improve
Well, I
MS
don't know.
Paint.
Some people doing same stuff that I can't even explain easily.
Yeah.
But yeah, this is what one PhD student is doing.
Do you have like plans after your PhD to go join FANG or something, or do you
Mm.
like to continue in academia?
No, I do not want to go back to industry.
No? You don't like getting
No.
paid? That's not.
I like being happy more than I like getting paid.
Oh, yeah, yeah. I. Wait, so that means you've been in industry before?
Yes, I was in industry before.
Oh, so I see. Interesting. So you're saying I could also probably go for my PhD now that I've been in industry a bit, because I
Yeah, you
like
could,
being happy too,
especially if you
man.
find, well, especially if you find like something that like interests you and you can like work a lot, on it, and like I don't know. So sometimes you don't get fulfillment from like just being a software engineer.
Yes.
But like for example, you do get fulfillment from what I see from like working on your website or projects. For
Yeah.
example, coding for me is like usually like I don't know, I enjoy maybe like 3 hours per week, maybe 5 hours per week can be enjoyable. But if I have to do more coding than that, it just becomes not fun, annoying, like tedious,
Ah,
and so on. That's why
I
sometimes
see.
like when I read a problem, I just solve it mentally and like okay, I think I have a solution, and I don't actually implement.
Yes, yes. I do that sometimes too, where I just get lazy to implement. But I hear you about industry not being very fulfilling. I think I'm going through
But
that right now, where I'm not sure if I want to be working in industry.
yeah, but what I also want to say is that like I'm kind of, I don't know, I'm kind of the exception, because like I know a lot of like people that like I'll never be able to reach the like algo skill level, or like they're just way beyond what average people can achieve. And they love
Yes.
industry, like they go to industry and they like stay at Google for 10 years and love it and just talk about how amazing Google is, and then they're like LGM on CodeForces or whatever.
Right.
So like I'm probably more of the exception than the norm.
Yeah, I see. I mean, yeah, I mean, I'm sure there's tons of people that will always be better than you, even if you're a tourist, apparently, because now tourist isn't the best anymore, right? Or,
Well, he's the highest rated right now,
but
right?
you say he just got beat by somebody at that contest,
I mean, when
or
uh,
he's still basically the number one. I thought somebody was coming for him, like some teenager from China. Maybe not.
yeah, I think the second place. Yeah, second place. They've been fighting
Yeah.
each other. BetSimp is a fanboy of this second place
Oh
person.
yeah. Yeah, I swear somebody got 4K and they made a new name for them on CodeForces.
Yeah, they made a name for tourist initially as well. Like you can see the
Yeah.
tourist has like tourist there and
Oh, Max 4K Taurus.
yeah, and if you
Oh,
look at the
maybe.
second place
Yeah,
one,
Taurus was the
he
guy
has
who.
max. He has max
Oh,
4K a bit
wow.
higher, and it's also his name.
I see. Interesting. Man, maybe I should start doing CodeForces. If I
Yeah,
think.
you could. Oh yeah. Here's one more thing that I like kind of wanted to mention, but it's like, uh, CodeForces actually has like if you make an account and go to edu,
Or like educational
there's
contests.
no, they have like this course, and like if you press enroll, they have like lots of secretary problems. They literally have, uh,
Well, I don't know what my account is, but I'll try and remember it. Edu.
yeah, they have literally have like 35 secretary problems. Just
Oh
that
yeah.
you're given the fact that they're secretaries.
Yeah, I think LeetCode is becoming more and more. I've never done CodeForces, but it feels like the problems in the contests are just becoming way more difficult than anything I've ever seen on LeetCode before. So it feels like I'm being forced to like go to CodeForces if I want to stay competitive in
Yeah.
some
It's like kind
ways.
of
Yeah.
they're trying to up the game because of LLMs.
Yeah. Well, thank you very much, Don't Defense, for our lovely course on segment trees. I think I'm not afraid anymore, at least for
Yeah. So
now.
don't forget. So one more thing I wanted to mention is like what type of operations you can do on secretary. So you can do, for example, sum, max, min, like these kinds of operations.
Okay.
So you should think about them like if the operation is like easy to combine two intervals in, then like it's easy to do. So for example, like sword you can do and like what Raxo is saying, any associative operation if you want to be theoretical, but I'm not sure if you know what an associative operation is.
Oh, what operation he said?
Associative.
I don't know what that is.
Exactly. So basically any operation that can be done like kind of quickly. Like for example, an operation that can be done is like count the number of unique elements, right? So what can you store in an interval to count to be able to merge two intervals? Well, you kind of need to store everything, right? If you just store the number of unique elements and you're trying to merge the left and right, well, it depends what elements, because if they're equal, then the number of unique
Yes.
elements doesn't change because you're just merging
Yes.
them. But if they're like completely different, all the elements are different, then it just gets summed up together, right? So not all operations are trivial to do
I see.
with
So,
with that.
but most of the basic ones will be some type of min, max, or sum for LeetCode.
Yes. Yeah, exactly. So if you think you can combine two intervals and you can store some small amount of information so that when you calculate the bigger interval, you can easily combine them, then yeah, that you can do that with a segment tree.
All right. So, how do you feel about type racer while on voice chat? Is that something you're interested in?
Let's sure
Because
let's do it.
Q Ultimus redeemed the type racer a while ago and we
I
haven't done it
saw.
yet. All right. So, I'll create this racetrack. First race is the warm up. Everybody knows that. Second race, championship round. Don't Defense is on the call with me. Don't Defense is one of the fastest typers in this community. All right. Maybe it's a little bit more nerve-wracking when people can hear you. I don't know if you get
Hopefully,
angry
if
for
NCC will
real.
be here, I might need to mute myself while I
No.
swear.
All right, here we go. Easy warm-up. Whew. You have a special keyboard or just regular stuff?
Yeah, I have like the Digma Race 2, which is like split.
Okay. Here we go.
Close.
Oh man.
I,
Dang, that's
I needed the warm up indeed.
Yeah, that's just the warm up. Pat's Hello World, a hundo. Stilled
Also,
113.
I,
What's up?
I cleaned up my room. I installed my DSLR as a webcam, but only then I realized that it's probably complicated to also show my face while teaching. But I had everything set up. I had like a
Oh.
good lens installed.
Oh man, you wanna show real quick? I'm down. I mean,
Let's do it after the type racer.
okay. Let me change to the Type Racer championship round time. I'm sure everybody's wondering what you look like or something, man. Like I'm
Well,
always
I did stream 2 times.
Yeah, I know what you look like, but I'm always excited to see what people look like after we've interacted online, you know? Alright, here we go, here we go. Championship race coming up.
Oh, come on!
Man, dang, 128. That's the fastest I've ever seen you type, man. What a great performance. Only
But
to
someone
be
had to ruin it, didn't they?
Yeah.
Somebody is like on my top enemy list. I could have had this like nice victory live on chat, but no.
Well,
Now he comes here, he like cock blocks me, and like NCC is still ahead. But when NCC races without me, like Pixel Pusher is nowhere to be seen. Like where could Pixel Pusher be? Oh, NCC is racing, Pixel Pusher is sleeping.
oh man.
Don't Defense is racing, wide awake.
Wait, I forgot how much that was. Was it 166? Let me put it up on the website.
I think he should be disqualified. I don't think he should be allowed
Nah,
to
he's
promise he's gonna stop at 75.
Nah, he didn't promise. He said he was thinking about it. He said 75 or 100. And I think he's going for 100. Wait, 166 was it? I'm just gonna put 166. All right. Well, what else should we do, man? Is this it? Is this the end of the lesson? Don't defense.
Yeah, let me say hi on camera, I guess, if you can see me. Is this the
Oh,
correct
I
camera?
can see you, man.
Yeah.
All right. You
Use
guys
the
ready?
fancy lens,
Wow.
fancy camera, use the
Amazing
fancy
quality.
microphone.
Are you guys ready? wait, let me. There we go. Introducing
Nice background effects,
Yeah.
right? Like this is just from the lens.
Grandmaster Don't Defense. Somebody from YouTube was asking, where is the master from? Brian Hernandez Mora from YouTube wants to know, where are you from?
I'm from Romania.
He's from Twitch.
Emigrated to America.
From Romania.
And nice to say that I'm finally an American citizen, so I cannot get deported.
Oh, congratulations. I mean, maybe it could.
I can criticize the current administration. I can like say whatever I'm safe, hopefully.
Yeah,
I
so
finally got freedom of speech.
so now that you've set up the webcam and the fancy microphone, are you thinking about doing some more streams or
I don't know, probably not, but maybe. I won't say no. Like so I'm using this like for example when I have to do a uni presentation or record myself.
yeah.
Uh
Yeah, it looks real nice. How about playing
but
some games?
currently I don't have plans. Maybe playing some games.
What
But
games
who knows?
are
Like,
you into these days?
I mean, I'm into like literally everything. I'm currently trying to become good at StarCraft 2.
Man,
I had
StarCraft
like a goal
2.
to.
What year is it, man? People still play that?
Of course, lots of people still play it.
StarCraft 2. Alright, what's your actions per minute? I mean, you type fast, so
About like 160, 200, so not that much.
I don't even know
I'm
what's
a
good, but
I'm a dirty Protoss player, so like I'm slow.
alright, StarCraft 2. Real Raymond Jones wants to know what rank are you?
I'm trying to get master.
Dang, I don't even know people play
I'm close to
StarCraft
master,
2
but
like that these days.
people keep asking clown builds like Skytos. Of course, I'm not playing Skytos. I'm trying to like, I'm trying to become good at the game. I'm not trying to clown around.
Alright, so you're very serious about StarCraft 2. How
Well,
about
not very serious, but when I do a thing, I actually want to improve at it. I don't want to just, just do it for. Especially like if you can improve at it, I don't want to just do it just for the sake of doing it. Usually, I like to. The things that I do, my hobbies are usually like have some level of like improvement to them.
so you're super competitive even in video games. Like you don't like to just relax.
Simon, I'm so competitive that like I'm desperate to get top 2 on your random website type racer ladder board. Do you think
Yeah.
I'm not? What signals to you that I'm not very
I mean,
competitive?
maybe you might need something to balance you. Like, do you play Minecraft creative mode, Nothing like that. It's too boring.
Sometimes I play relaxing games, but like competitive is like where it's at.
Yeah. I see. I get that. I used to be more competitive. These days, I like to just chill. I play most games offline, actually.
Yeah, I think I also play like most games offline when I like want to
Yeah.
relax, like relaxing games or like story games. But when I play like a multiplayer game, the problem is that I like want to become really good, so I just invest a lot of time in them. So I usually have to like take a step back to not
Yeah.
waste too much time, let's say.
Any other hobbies that you have besides something inside on the computer and photography, it seems?
So like taking photos. My lovely chickens. I
You
have
got
two chickens.
chickens? Whoa.
Yes, I
Wait,
have two chickens and three dogs.
it's incredible.
None of the dogs are in the room with me right now.
Do you have these chickens for eggs or just as a pet or something?
For, for both eggs and as a pet, like they're chickens.
So you eat these
I mean,
chicken
they lay eggs and they're
eggs
pets as well.
every week? How many eggs do you get a month?
So we get more eggs than we're eating. Like I think it's been months since we
I mean,
bought eggs.
in Stardew Valley, I get like 1 egg per day per chicken.
Yeah, so you kind of get one
that
egg
true?
per day per chicken during like the non-winter months.
All right. Dang, I didn't. Dang. How the hell do they make a whole ass egg every single day, man? That's crazy.
Yeah, it's crazy. And one of them makes green eggs, so it's like very adorable when you like get random green eggs.
Wait, green eggs all the time, or it's like a random
Yeah,
rare
all the
drop?
time.
Wow.
All the time.
Is it based on what they eat, or is it like a special
I
chicken?
think it's genetic based on them.
Man, I didn't know you're into like having a little farm over there.
Yeah, here's a picture of one of my chickens. Oh, wait. Can
Oh
you
wow.
see? Yeah,
Wow, that's a
this is the first. This is the one that makes green eggs.
that kind of looks like Pidgey from Pokemon. I'm not gonna lie. So very nice.
It kind of looks like a Pokemon, and then let's see if it focuses. Okay. This is both of them. Anyway, that's somehow. So usually like I also like in I don't know I also like improving things. So I usually start on a hobby and do it until I feel like I reach like an improvement level that I feel like happy with, and then I just put it as a maintenance mode hobbies.
I see. Yeah. Well, you got a lot going on over there, Don't Defense. You're like very accomplished in so many different things. I think we could all learn a little bit from you, man.
My two main accomplishments: competitive programming and chicken owning.
Yeah, that's pretty good. And type racing. I think you're top type racer in the stream now, besides Pixel
Don't
Pusher.
remind me about Pixel Pusher sniping me on my stream day.
Yeah. Anyways, what else is in store for you in the future, you think?
I have no idea. What's in store for your future? Maybe like what are you doing tomorrow, Simon? You should be
Tomorrow?
telling
I'm
us
getting
what's.
married tomorrow, man. Look, I already wear my
Congrats.
ring. It's not even like a traditional wedding band, it's a smart ring. So,
Congrats, very exciting. I I've been taking ever since I realized that Clayster is like um is your like girlfriend, future wife. I was like, man, I saw her on the stream so much. I followed her on Instagram and talked with her, but then somehow I just didn't connect. I did
man.
just whenever I was reading her Instagram handle, I was reading like all of it, so I didn't connect that it's the same person. So I was like very
Yes, it
shocked.
is the same person because you bought a bag from her, man. How do you think
Yeah,
I knew she makes bags?
my wife, that's like her most used bag.
Oh, thank you everyone in chat. I am getting married tomorrow. It's gonna be a wedding at the courthouse or whatever, the city hall. So it's gonna be a big day for me for sure. But nothing's changing really. We're already living together and we're basically married already, you know. Oh man. So am I going to stream the wedding? I was thinking about it, but I don't think I will.
You are really thinking about it. That sounds kind of like the quickest way to divorce. I'm not gonna lie. That sounds like
No, well, I don't know if I'd do it on Twitch
you,
publicly, but I was going to at least to like my family because no one's coming. Like my parents are not here. All my siblings are in different areas of the world, you know. So
okay, that's good. I thought you were about to speedrun marriage.
yeah, I mean maybe. No, not maybe. This is for life.
Right, congrats again. Hopefully you enjoyed the Sec 3
Yeah.
lessons.
Thank you very much. I did, and I think you've made them a lot less scary. At first, I was very confused. I'm not gonna lie, though. That's only because of the way you've implemented it. It was unlike anything I've implemented before.
Yeah, so
You
so
know.
like it's I kind of like, gave you the like instant this is like how you should do it method
Yeah.
instead of like doing some like slower methods that might be more intuitive.
Yeah. Yeah. Well, thank you so much for that lesson. And I still have a few things I need to learn. I need to learn rolling hash stuff or any type of string hashing, and maybe that's like the final piece to like complete my Guardian roadmap.
Yeah, if you want, I can always teach you that. You can also always diversify and like Brett taught you Fenwick trees.
Yes.
Betsim taught you
Digit
DGDP. I
DP,
taught you
segment trees.
Sec trees. So maybe like you get a fourth guest star
Yeah, maybe we'll
for
see
rolling cash.
who else is
Maybe you
out there.
convinced Kiki or someone. But
Chi Chi
if you
or
want, I'm
yeah.
always I'm always available.
Oh, there's Raxo also. Man, Chi Chi's taught me a lot, man. What are you talking about?
Wait, did he come on stream? I
Oh no,
didn't.
he's never been on stream, but he's
Well,
like helps
yeah,
me,
but that's what
you
I'm
know.
saying on stream.
Yeah.
Guest star.
Anyways, I will think about the next steps for me with like guest teachers on here. I like to bring more people on. I think there's a few people in mind, like Glump, I know is really good. There's No Condom Chris. I think everybody would love to hear from No Condom Chris. I mean, Chi
Everybody
Chi
would
Impact is
love to
there.
hear that no condom Chris had like a hand accident and can no longer do type race for 6 months. I think that's what people want to hear from no condom Chris.
Yeah. Oh, Chi Chi Impact will teach me React. Yeah, actually, man, I would really like that because I'm just freestyling with React, and it kind of makes sense. But I'm sure there's a lot to learn for me. All right.
All
I
right, it was
guess.
nice. It was nice
Yeah.
talking with you.
Yeah. Thank you so much, Don't Defense, and we'll see you in the chat. Thank you so much
Yep.
again.
See ya.
Adios. Take care. All right. There you go, everybody. That was segment trees with Don't Defense. What a nice guy. A lot different in person than in the chat, huh? Everybody knows Don't Defense in the chat gets a little excited over Type Racer and some other stuff, but wow. So nice, man. Wait, what? Anyways, what should we do now, man? Oh, Brian Hernandez, thank you so much. Tomorrow is the big day. This is basically my bachelor party, man. Might end it a bit early because, like, what do I do now? Do LeetCode? I just did some LeetCode, man. Should we go raid somebody? Is anybody streaming? How is Don't Defense so much nicer on camera? Yeah. Don't Defense always nice? Maybe. Pat, where you at, man? If you get online, I'll go raid you right now. Courthouse wedding line is such a fun vibe. But you make friends in the line? Oh yeah? I've never been to a courthouse wedding. I didn't even know there's a line like that. It's gonna be interesting. It's tomorrow. I just got my marriage license today, and you need to wait 24 hours before you get married. So it's gonna be like 28 hours from the time I got my marriage license to when I actually get married. My brother's also doing the courthouse wedding thing in San Francisco. Yeah, I think the courthouse is the way to go, man. I mean, maybe somewhere down the line we'll have something more formal, but I don't know. I think this is nice, just courthouse. Then they went into the courthouse. Wait, I officiated Friends in New York about 10 years ago, and then they went in the courthouse to make it official. There's a nice park in front of it, but it's probably gonna be gross tomorrow. Huh. Save on taxes this year. Yeah, I'm looking forward to that for sure. Anyways, try and stream a little bit early and get out of here, man. I've been playing this dang game, Expedition 33, and it's pretty good. I like it a lot, man. This is like the first game or RPG game that I've played and gotten this far in a long time. It really reminds me a lot of Final Fantasy games when I was younger. I'd say it gives me a lot of, like, I don't know, I keep thinking of Final Fantasy X when I'm playing it, but it's like way more mature or whatever. Like, the setting is a lot more dark, you know. My friend says that it might be game of the year. Yeah, I think definitely it might be a game of the year. I don't know what else games came out this year though. Schedule 1 is also really good. Good story. Yeah, great story. I really feel it's kind of like watching a dang TV show on Netflix, you know. Hope next Doom is going to be cool. Next Doom? They're still making a Doom, man? GTA 6 ain't dropping this year. Yeah, I heard. I don't even know if I played GTA 5, man. But this game has been really good. I'm probably about to go play it right now, man. It's very annoying, though, because it's hard. Anyways, actually, I'm not about to go play video games. I'm about to go see if I need anything for my wedding outfit. I'm a JRPG fanatic, but the art style dialogue isn't really my thing. I might give it a shot though. Man, sorry. Chi-Chi Impact. This game is so good, man. I guess the art style isn't very J-like or something, but the story is very intriguing for me, and there's a lot of, like, you just kind of want to know what's going on in this world. I think they do a really good job at slowly revealing the universe to you, and it really draws you in, man. And there's a bit more violence than in like Final Fantasy games, I'd say. Uh, I haven't played a JRPG in a long time like this. Like, probably, dang, what was the last JRPG I played? I can't even tell you, man. It's been that long. Yeah, this is probably it in like a decade. Elden Ring will drop out another DLC this year. Man, I haven't played Elden Ring either. I should probably try it. The story is really interesting. I agree. It's not every year that a JRPG completely takes over the streaming meta, so I might have to. Yeah, it's really fun, man. I think they do a great job at mixing like a typical turn-based JRPG with some type of like more real-time elements. And the real-time elements, I guess, is like Souls like dodging and parrying and whatever. Uh, and then, yeah, I'm still learning a lot about the game, but I've been really enjoying it, man. So, highly recommend. Anyways, who's gonna get on so we can raid them? Or are we going to just raid somebody who's already online? Maybe Samir or Smokey777.
This one time, my
Oh, Hector HSC. Thank you so much. Man, I think I forgot. Oh wait, let me do that right now. Hector HSC gifted some bits while we're going through our lesson, and I did not put them on the board, so let me put them on the board right now, and then I'll go raid somebody. Simon Variety Stream? Fantasy, what's happening? Nah, I don't think, I mean, I'm a variety streamer now. I stream LeetCode and I stream web dev. That's pretty much a variety to me. Maybe one day I'll stream games, but I don't think it's coming anytime soon. I mean, maybe this year I might do 1 or 2 game streams. You never know. You never know what the future holds. Alright, who's this person? Smokey777 doing LeetCode. There's a lot of people in here. Are we ready? Let's go raid them. LeetCode is sort of a game? Yeah, kind of. Where's my chat? Co-op game? AI VTuber? Wait. I guess. AI generated? What does that mean, man? Should we check it out? No, it's like a person. I can hear them typing. Anyways, let's go see what they're all about. Anyways, thank you very much for tuning in. It was a very nice stream today. We got the lesson from Don't Defense on segment trees. And what else did we do? That's about it. Got to talk with Don't Defense. I'm getting married tomorrow, so next time you see me, I'll be a married man. Maybe I'll send some pictures in my Discord. But thank you everyone for tuning in, and see you on Wednesday. Real Raymond Jones, see you next time. Raxo Sabe, have a good night. Pat's Hello World, see you later. R-Fire, have a good night. Thank you for tuning in. Stilled, Chi-Chi Impact, Q Ultimus, have a good night. Thank you for tuning in. Crunk Master Cash, have a good night. Thank you very much for tuning in. Bobby Blue, see you later, alligator. Don't Defense, thank you so much for the lesson, and I'll see you next time. Brent Arata, also thank you for tuning in, and I'll see you next time as well. Everybody who's lurking, have a good night. Everyone from YouTube, Brian Hernandez Mora, see you later. Hector HSC, adios amigo, thank you so much for the bits. And everybody who I missed, thank you so much. Pixel Pusher, have a good night. Ice Cold Witch, AKSR41, and everybody, see you next time.